So now we're going to conduct required practical number 8 to measure the wavelength, the frequency and the speed of waves on a ripple tank. Now you need a piece of paper because you're going to take the results from this experiment. Now a note about how the ripple tank works is there is a little tray of water here sat on top of a window, transparent bit of glass. And what happens is the light source from the top shines through the water, hits the mirror, and then you see the shadow of that water on the screen just there. And that's where you're going to be looking. Now, in order to do this experiment, we need to film it in slow motion. And we can do that with a camera. But that requires disabling part of this apparatus. If you're setting this up for yourself, you will have to take off the small little rotating wheel, which causes the light source to flash and flicker. You'll need a constant light source for this experiment. Now, the very first thing that we're going to measure is the wavelength, the distance between one wave peak and the next. Now, if we're measuring a distance, we need to do it with a ruler. And so what I've got is a ruler up the side here, and you may have to add one to your apparatus if you're doing this at your school. Now, the ruler it can be used to measure a single wave, but what I suggest that you do instead is that you use it to measure 10 waves, and we'll have a go. Now, in order to measure 10 waves, what I'm going to have to do is take a still image of the waves as they progress, and you're going to have to look at count 10 waves and then measure the length on that ruler of the 10 waves in the photograph. To create the waves, all I'm going to do is I've disabled the automatic vibration of this device. I'm just going to tap it like that, which is going to produce a whole load of waves across the front. And they're the waves that you're going to measure. So one more time, when I tap, that is what you're going to measure. So what did you notice? You noticed that there wasn't actually 10 on the screen, there was only about 4. Now that's okay, we just measure the distance across 4 of them instead and divide that answer by 4. So however many you can clearly see, you measure that distance and then divide by that number. So what you need to record, first of all, is the length of, for example, 4 waves. 4 complete waves. If that was equal to 8 centimetres, and this is just an example, so you're going to have to take it from the still image, then what I know is that the wavelength, which is given by the symbol lambda, is going to be equal to 8 centimetres divided by 4, which is equal to 2 centimetres. That is how long each one is. Later we're going to need to convert this into metres, so we might as well do it now. So your answer, divide it by 100 to get it into metres. So 0.02 metres, that is my wavelength. Now you need to do this on that still image from the ripple tank. The next thing we need to measure is the frequency. Frequency is defined as the number of complete waves that occur in 1 second, or the number of complete waves that go past a point in 1 second. So now we need to measure the number of waves that go past in 1 second. Go past where? This arrow is the point we're going to measure them going past. Now I think basically we could do it for 1 second. Well, there's 2 approaches here. We could do it for 10 whole seconds, or alternatively we could do it in slow motion and measure across 1 second. If we did it how many passed in 10 seconds, there's going to be an awful lot of them. So I think actually the better way for us is to use the slow motion feature of the camera. For example, I will press start on this stopwatch, and in 1 second, how many waves go past that blue arrow? Well, let's see. 3, 2, 1. You see, 2 seconds went by there. Were you able to count how many waves went past? No, of course you weren't. So let's do it in slow motion instead. So how did he get on? Well, it's difficult because there is a pulse of waves, and those waves don't always appear to be evenly spaced. But what you could do is you could take a certain number of waves that you've counted passing that marker. The number of waves that pass divided by the time that they go past is actually another way of working out the frequency, because that ratio there, the number every second, is exactly what frequency is. So imagining that, for example, that 8 went past in 2 seconds, then my frequency would be 4 Hertz. That would be my frequency. Now hopefully from the video you can work out what the frequency of those waves were. The very final step is we need to be able to calculate the wave speed. And we do that using the wave equation. V equals F, the frequency, times lambda, which is the wavelength. Now we have up here in our example 4 as the frequency and 0.02, which means our wave speed is 0.08 meters per second, or alternatively it is 8 centimeters per second. Using the data that you have collected, can you work out what the wave speed was on the ripple tank?